And now in this lecture we'll find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. This is angle ADC, this is the right angle. This is angle ABC, this is also right angle. This is side AB, this is equals to 10 units in Islam. This is side DC, this is equals to 25 units in Islam. This is angle BCD, this is equals to 45 degrees in its size. Again, our task is to find out the area of this quadrilateral ABCD. So we start with the first method, and from point B we will draw perpendicular on DC. Again, from point B we will draw perpendicular on DC. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B, and DC, this point is point N. In the next step we will do another construction. That is to say, from point A we will draw perpendicular on BN. Again, from point A we will draw perpendicular on BN. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BN. This point is point M. When doing this construction, what you want to do, quadrilateral AEM and D. Inside this quadrilateral AEM and D, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this four-piece angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this four-piece angle must be equal to 90 degrees in its size. So inside quadrilateral AEM and D we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this left angle in front of the square. So we write to quadrilateral AEM and D as a left angle because it has 4 right angles. So as you know, this is quadrilateral AEM and D. It is a rectangle according to rule 5. We define the length of side AEM as A. We know that the opposite sides of a rectangle are equal to each other. So rectangle AEM and D, side AEM must be equal to the opposite side DN. But AEM is A, therefore the opposite side DN must be also equal to A units in its length. In the next step we will focus on the right triangle ANC. This is the right triangle ANC. This right triangle ANC, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle BNC? We have this angle equals to 90 degrees, plus this angle, that is 45 degrees, plus the missing angle, that is angle NBC. In total, the sum of those 3 angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. 90 degrees plus 45 degrees is 135 degrees. So 135 degrees plus the missing angle NBC. In total, the sum of those 3 angles must be equal to 180 degrees. Here we subtract 135 degrees from this equation. We get that the missing angle NBC is equal to 180 degrees, 135 degrees is 45 degrees. This is angle NBC equals to 45 degrees in size. This is angle NBC. This is equal to 45 degrees in size. So actually, triangle BNC is a right triangle that is also an isosceles triangle because those two angles are equal to each other. So it is a right triangle that is also an isosceles triangle. And we have the rule that in front, so those two angles are both equal to 45 degrees in their side. What is the length of NC? NC, from the drawing it is very easy to see that NC equals to DC minus DN. Again, DC minus DN equals to NC. But again, NC equals to DC minus NC. Again, NC equals to DC minus DN. Again, NC equals to DC minus DN. So I write it down. NC equals to DC minus DN. So NC in total equals to DC equals to 25 units in its length according to what is given as the question, minus DN. DN is A. So in total NC equals to 25 minus A units in its length. So actually, this is side NC. This is equals to 25 minus A units in its length. We know that in front of equal angles in the triangle, there are equal sides. So in front of those two equal angles in triangle A and B, we have equal sides. In front of those angle, we have side BN. In front of this angle, we have side NC. So side NC must be equal to side NB. But NC is 25 minus A, therefore NB must be also equal to 25 minus A units in its length. This is side BN that is equals to 25 minus A units in its length. According to the rule that in front of equal angles in the triangle, there are equal sides. In front of those two equal angles, we have those two sides that must be equal to each other in their lengths. But the size of angle NC is 25 minus A, therefore the size of side NC is 25 minus A, therefore the length of side BN must be also equal to 25 minus A units in its length. The next step will focus on the right triangle, triangle ABM. In the right triangle ABM, but before that we focus on the big angle ABC equals to 90 degrees. 90 degrees minus 45 degrees equals to this missing angle. Again, 90 degrees minus 45 degrees equals to this missing angle. So 90 degrees minus 45 degrees is 45 degrees. So in the right triangle ABM, this angle equals to 45 degrees, this angle equals to 90 degrees, and therefore this missing angle must be equal to 45 degrees in its size, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. And we have in front of those two equal angles, we have those two sides that must be equal to each other in their lengths. So in front of this angle 45 degrees, we have AM that is equals to A, and in front of this angle 45 degrees, we have side BM, and AM must be equal to BM according to the rule that in front of equal angles we have equal sides in a triangle. But AM equals to A, therefore BM must be also equal to A according to the rule that in front of equal angles in the triangle there are equal sides. Those two angles are equal to each other, therefore those two sides that are located in front of those two equal angles must be equal to each other in their lengths. But the length of AM is A, therefore the length of BM must be also equal to A units in its length. What is the length of MN? MN equals to BN minus BM. Repeat again. MN equals to BM minus, again, MN equals to BN minus BM. So MN equals to BM. BM is 25 minus A minus BM. BM is A. So MN equals to 25 minus A minus A. 25 minus A minus A is 25 minus 2A. So in total we found out that Mn equals to 25 minus 2A units in its length. So this is side Mn, that is equal to 25 minus 2A units in its length. We know that the opposite sides of rectangle are equal to each other. So in rectangle AM and D, side MN must be equal to the opposite side AD. But MN is 25 minus 2A, therefore the opposite side AD must be also equal to 25 minus 2A units in its length. So AD equals to 25 minus 2A units in its length. Our task is to find out the area of this quadrilateral ABCD. So what is the area of quadrilateral ABCD? Actually, the area of quadrilateral ABCD is equal to the area of trapezoid A, B, and D. This is trapezoid A, B, and D. Minus the area of this right triangle, triangle B and C. Repeat again. The area of this quadrilateral ABCD equals to the area of trapezoid A, B, and D again, the area of quadrilateral ABCD equals to the area of trapezoid A, B, and D plus the area of this right triangle B and C. Repeat again. The area of quadrilateral ABCD equals to the area of trapezoid AB and D, the area of this trapezoid AB and D, plus the area of this right triangle, triangle B and C. A trapezoid is a quadrilateral with one pair of parallel sides. So why AB and D is a trapezoid? Because first of all we know that the opposite sides of a rectangle are equal to each other. So in rectangle AM and D, side MN is parallel to side AD. Again, according to the rule that the opposite sides of a rectangle are parallel to each other. So in rectangle AM and D, side MN is parallel to the opposite side AD. But this angle equals to 180 degrees. Therefore, we know that any angle that is equals to 180 degrees in its size, it is defined as a straight line. And therefore, BN is a straight line because this angle equals to 180 degrees. BN is a straight line. Part of the straight line BN is parallel to AD. Why? Because MN is parallel to AD. And we know that if a part of a straight line is parallel to another straight line, then the straight line itself, BN, must be also parallel to AD. So BN is parallel to AD, and therefore in quadrilateral A, B, and D, we have one pair of parallel sides. That is to say, BN equals to AD. And therefore, quadrilateral A, B, and D is a trapezoid because it has one pair of parallel sides. BN is parallel to AD. And we know that the area of a trapezoid is equal to the sum of its two parallel bases. This is actually BN plus AD times the height, MA, divided by 2. So we found out the area of this trapezoid A, B, and D equals to the sum of its two parallel bases, that is BN plus AD, times the height AM. The height AM creates 90 degrees. We do two parallel sides, BM and AD. So this times the height AM over 2. I repeat again, and we found out that the area of this trapezoid AB and D equals to the sum of its two parallel bases, that is actually BN plus AD, times the height AM over 2. Plus the area of this right triangle B and C. The area of triangle B and C equals to the base NC times the height BN over 2. Repeat again, the area of the right triangle B and C equals to the base NC times the height BN over 2. BN equals to 25 minus A plus AD. AD equals to 25 minus 2A multiplied by AM. AM equals to A divided by 2. Plus the area, so in total, the area of trapezoid A, B, and D equals to BN, that is 25 minus A, plus AD, that is 25 minus 2A, times the height A over 2. Plus the area of this right triangle B and C. The area of the right triangle B and C equals to the base NC, that is 25 minus A, times the height BN, that is also 25 minus A, so actually in total it is 25 minus A squared divided by 2. So in total the area of trapezoid ABCD, the area of this trapezoid ABCD is equal to, we have 25 plus 25 is 50. We have minus A minus 2A is minus 3A times A over 2 plus 25 minus A squared over 2. 25 minus A squared is 25 squared, that is 625, plus A squared minus 2 times 25 times A, that is minus 50A divided by 2. 50 times A is 50A, minus 3A times A is minus 3A squared, and we have plus 625 plus A squared minus 50A divided by 2. 50A minus 50A is also those two expressions will get cancelled, and we have minus 3A squared plus A squared is minus 2A squared plus 625 over 2. So in total we found out that the area of quadrilateral ABCD equals to 625 minus 2A squared divided by 2. This is the area of quadrilateral ABCD. Repeat again, the area of this big quadrilateral ABCD, in total it is equals to 625 minus 2a squared over 2. Here we will implement the Pythagoras theorem on this right small triangle ABM. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I'll copy this right small triangle ABM in a new page and we will implement on it the Pythagoras theorem. Here by PT is the progression of Pythagoras theorem. So actually, this is the right small triangle ABM that according to the original theorem. This right triangle ABM, according to the Pythagoras theorem, AB squared, that is the square of the hypotenuse, equals to BM squared plus MA squared. So write it down. AB squared, that is the square of the hypotenuse, equals to BM squared plus AM squared. Again, according to the Pythagoras theorem, in this right triangle ABM, AB squared, that is the square of the hypotenuse, equals to BM squared plus AM squared. AB is 10, therefore AB squared is 10 squared, that is 100, equals to BM squared. BM is 8, therefore BM squared is 8 squared, plus AM squared. AM is also 8, so AM squared is 8 squared. So in total, A squared plus A squared is 2A squared. So 2A squared equals to 100. 2A squared equals to 100, and therefore we can substitute 2A squared in this equation by 100. We will do it now, we get that the area of quadrilateral ABCD equals to 625 minus 2 times A squared, and 2 times A squared is 100, so it is minus 100 over 2. 625 minus 100 is 525 over 2. 525 over 2 is 262.5 square units. So in total, we should find out that the area that we are looking for in this question, that is the area of this quadrilateral ABCD, is equal to 262.5 square units in size. So we finish with the first method. In the next step, I present to you how to find out the area of this quadrilateral ABCD according to the second method. In the second method, we will extend side DA and side CB by a straight line until they touch each other. And again, we will extend side DA and side CB of this quadrilateral ABCD by a straight line until they touch each other. And when you find the touching point of the extended side DA with the extended side CB, this point is point M. By doing this construction, we get the big right triangle MDC. This is the big right triangle MDC. We know that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in the right triangle MDC? We have this angle that is right angle, plus this angle that is 45 degrees, plus this missing angle. In total, they must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. 90 degrees plus 45 degrees is 135 degrees, and therefore this missing angle must be equal to 45 degrees in its size. 45 degrees plus 45 degrees is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. We know that in front of those two equal angles in the big triangle, the big right triangle MDC, in front of those two equal angles, we have two sides that are equal to each other. So in front of this angle we have side MD, in front of this angle we have side DC. So in front of those two equal angles we have those two sides that must be also equal to each other in their lengths. But DC is 25, and therefore MD must be also equal to 25 units in its length, according to the rule that in front of equal sides, in front of equal angles in the triangle, they have equal sides. DC equals to 25, and therefore MD must be also equal to 25 units in its length. So DM equals to MD equals to 25 units in its length. The hypotenuse MC is absolutely a straight line. So if we focus on the left side of the straight line MC at point B, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of the straight line MC at point B? We have this angle that is 90 degrees, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So, in the right triangle, the small right triangle A and B, this angle equals to 90 degrees, this angle equals to 45 degrees, and therefore this first missing angle must be equal to 45 degrees in its size. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. In front of those two equal angles in the small right triangle A and B, we have those two sides that must be also equal to each other in their lengths. But AB is 10, therefore MB must be also equal to 10 units in its length. Our task is to find out the area of quadrilateral ABCD. So what is the area of quadrilateral ABCD? What is the area of this quadrilateral ABCD? Actually, the area of this quadrilateral ABCD equals to the area of the big right triangle MDC minus the area of the small right triangle ABN. Repeat again. The area of quadrilateral ABCD equals to the area of the big right triangle MDC minus the area of this small right triangle MBA. Repeat again. The area of quadrilateral ABCD equals to the area of the big right triangle MDC minus the area of the small right triangle ABN. The area of the big right triangle MDC equals the area of the big right triangle MDC equals to the base DC times the height DM divided by 2. Repeat again. The area of this big right triangle MDC equals to the base DC times the height DM over 2. Minus the area of this small right triangle ABM. There's on the small right triangle ABM equals to the base AB times the height BM divided by 2. And again, the area of this right triangle ABM equals to the base AB times the height BM over 2. DC equals to 25. DC equals to 25 times DM. DM also equals to 25 divided by 2. So in total we should find out that the area of the big right triangle MDC equals to the base DC times the height DM over 2. That is 25 times 25 divided by 2. Minus the area of this small right triangle ABM. This AB is 10 times BM is also 10 divided by 2. So the area of this small right triangle ABM equals to 10 times 10 over 2. So in total the area of quadrilateral ABCD equals to 25 times 25 is 625 divided by 2. 10 times 10 is 100, so it is 100 over 2. So 625 minus 100 is 525 divided by 2. 525 over 2 is 262.5 square units in its size. So in total we should find out that the area that we are looking for in this question, that is the area of this quadrilateral ABCD, is equal to 262.5 square units in its size. So in both methods we arrive to the same result. So in the next step I will summarize the lecture. We'll start with the first method, of course. In this lecture we found out the area of this quadrilateral ABCD using two different methods. So let's start with the first method. In the drawing we have quadrilateral ABCD. Side AB equals to 10 units in its length. This is angle ADC, this is right angle. This is angle BCD, this is equals to 45 degrees in its size. This is angle ABC, this is equals to 90 degrees in size. Again, our task is to find out the area of this quadrilateral ABCD. So, first of all, we did a construction. That is to say, from point B we drew perpendicular on DC. Again, from point B we drew perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point N. In the next step we did another construction, that is to say from point A we drew perpendicular on BN. Again, from point A we drew perpendicular on BN. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BN. This point is point M. By doing those constructions we get the quadrilateral AM and D. Inside quadrilateral AM and D we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 pieces again. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Actually, inside quadrilateral AM and D we have 1, 2, 3 right angles. The 3 right angles are those 1, 2, 3. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 pieces again. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this uh, this 4 pieces again must be equal to 90 degrees in size. The three angles are 1, 2, 3 right angles, or it is 1, 2, 3 right angles, and therefore this 4 pieces again must be equal to 90 degrees in size. So therefore, for the other AM and D, we have 4 right angles, and therefore for the other AM and D is a rectangle because it has 4 right angles. We define the length of AM as A, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle AM and D, side AM must be equal to the opposite side ND, but AM is A, therefore the opposite side ND must be also equal to a unit in its length. What is the length of this missing line segment NC? NC equals to DC minus DN. So NC equals to DC minus DN. So NC equals to DC, that is 25, minus DN, that is A. So in total, NC equals to 25 minus A units in its length. So in triangle PNC, the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have? This triangle BNC, we have this angle is equal to 45 degrees, plus this angle that is 90 degrees, plus this missing angle. In total they must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So 90 degrees plus 45 degrees is 125 degrees, plus this missing angle. In total they must be equal to 45 degrees. Here we subtract 125 degrees from this equation, and finally found out that the missing angle NBC, this is the missing angle, is equal to 45 degrees in size. Therefore, triangle BNC is a right triangle that is also an isosceles triangle. In front of those two equal angles, we have those two sides that must be also equal to each other in their lengths. According to the rule that in front of equal angles in the triangle, there are equal sides. So in front of those two equal angles, we have those two sides that must be also equal to each other in their lengths. But the size of this side NC is 25 minus A, therefore the size of this side BN must be also equal to 25 minus A units in its length. We already found out that MB equals to A. So what is the length of MN? MN equals to BN minus VM. And MN equals to BN minus VM. So MN equals to BN. BN is 25 plus MN equals to BN. BN equals to 25 minus A minus MN. Again, MN equals to BN minus BM. So MN equals to BM, that is 25 minus A, minus BM, that is A. So total MN equals to 25 minus A, that is 25 minus 2A. In the rectangle AM and D, the opposite sides are equal to each other. So side MN equals to the opposite side and AD. But MN is 25 minus 2A, therefore the opposite side AD must be also equal to 25 minus 2A units in its length. Our task is to find out the area of this quadrilateral ABCD. The area of quadrilateral ABCD must be equal to the area of trapezoid AB and D plus the area of this right triangle B and C. Read again. The area of trapezoid and the area of quadrilateral ABCD must be equal to the area of trapezoid AB and D plus the area of the right triangle B and C. A trapezoid is a quadrilateral with one pair of parallel sides. Why AB and D is a trapezoid? Because of the fact that first of all we know that MN is parallel to AD according to the rule that the opposite sides of a rectangle are parallel to each other. But BN into angle BMN, this is angle BMN, this is equal to 90 degrees plus 90 degrees, it is 180 degrees. And you know that angle that is equal to 180 degrees in its size, it is defined as a straight line. Therefore, BN is a straight line. So if a part of the straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Part of the straight line BN, that is AMN, is parallel to side AD. According to the rule that the opposite sides of a rectangle are parallel to each other. Therefore, the straight line itself, BN, must be also parallel to AD. And because of the fact that BN is parallel to AD, quadrilateral AB and D is a trapezoid. So, and we know that the area of trapezoid equals to the sum of its two parallel bases, that is actually BN plus AD times the height MA over 2. Therefore, the area of this trapezoid AB and D equals to BN plus AD times the height MA over 2. Okay, again, the area of trapezoid AB and D equals to the sum of its two parallel bases, this is BN plus AD, times the height AM over 2. The area of quadrilateral ABCD equals to the area of trapezoid AB and D, plus the area of this right triangle A and C. So what is the area of this right triangle NC? It is equals to the base NC times the height NB over 2. Again, the area of the right triangle BNC equals to the base NC times the height BN over 2. BN is 25 minus A plus AD. Again, BN is 25 minus A plus AD. AD is 25 minus 2A. Again, AD is 25 minus 2A divided by 2 times the height. The height is AM, that is A. AM is the height, that is A. So in total, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is 25 minus A plus 25 minus 2A times the height A over 2, plus the area of this right triangle B and C. The area of the right triangle B and C equals to the base NC times the height NB over 2. NC is 25 minus A, and BN is 25 minus 2A. So again, NC is 25 minus A, and BN, again, NC is 25 minus A, and BN is also 25 minus A. So the base is 25 minus A times the height, that is also 25 minus A. 25 minus A times 25 minus A is 25 minus A squared divided by 2. So here we have 25 plus 25 is 50. Minus A minus 2A is minus 3A times A divided by 2. Here we have 25 minus A squared is 25 squared, that is 625, plus A squared minus 2 times 25 times 8, that is minus 58 divided by 2. Here we open the brackets in this expression, and we found out that 50 times A, we have 50 times A, minus 3A times A is minus 3A squared, and here we have 625 plus A squared minus 58. We have 58 minus 58 is 0, so those two expressions get cancelled. We have minus 3A squared plus A squared is minus 2A squared plus 625 over 2. So in total, we found out that this quadrilateral ABCD equals to 625 minus 2A squared divided by 2. And again, the area of this quadrilateral ABCD equals to 625 minus 2A squared over 2. In the next step, I copied this small right triangle ABM in an equation implemented on this right small triangle ABM, the quadrilateral theorem. According to the quadrilateral theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, this is the right triangle ABM, that is the problem from the original drawing. In this right triangle ABM, AB squared, that is the square of the hypotenuse, equals to BM squared plus MA squared. AB squared equals to BM squared plus AM squared. AB is 10, therefore B squared is 10 squared, that is 100, and this equals to BM squared. BM is 8, therefore BM squared is A squared, plus MA squared. MA is also 8, so AM squared is A squared. So in total, 100 equals to a squared plus a squared, this is 2a squared. So we found out that 2a squared equals to 100. So we can substitute 2a squared in this equation by 100. We did it, and we found out that the area of quadrilateral ABCD equals to 625 minus 2a squared. And 2a squared is 100 divided by 2. So 625 minus 100 is 525 divided by 2. 525 over 2 is 262.5 square meters in its size. So according to the first method, we found out actually that the area of this big quadrilateral ABCD is equal to 262.5 square meters in its size. We finish with the first method. In the next step, I presented to you to find out the area of this quadrilateral ABCD according to the second method. In the second method, we did a construction, that is to say, we extended side DA and side CB by a straight line until they touch each other at point M. We define their touching point as point M. By doing this construction, we created the big right triangle MDC. In the big right triangle, the sum MDC, the sum of the angles must be equal to 180 degrees. So which angles we have in the big right triangle MDC? We have this angle that is 90 degrees, plus this angle that is 45 degrees, plus this angle. In total they must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. And therefore this missing angle must be equal to 45 degrees in its size. In the right triangle MDC, in front of those two equal angles, we have those two sides that must be equal to each other in their lengths. But the side of DC is 25. We have DC equals to 25 units in its length. Therefore, MD must be also equal to 25 units in its length. Again, according to the rule that in front of equal angles in the triangle we have equal sides. Those two sides must be equal to each other, but this side DC is 25, therefore this side MD must be also equal to 25 units in its length. This angle, this is the missing angle. We know that MC is hypotenuse of the right triangle MDC. It is absolutely a straight line. So if you focus on the left side of the straight line MC at point B, the sum of the angles must be equal to 180 degrees according to rule 3 that said that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have if the left side of MC at point B? We have this angle that is equal to 90 degrees in size, plus this missing angle. In total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. So in the right triangle MBA, this angle equals to 90 degrees. This angle equals to 90 degrees. And this angle equals to 45 degrees. And therefore, this missing angle must be equal to 45 degrees in its size according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So the right triangle AMB is also an associated triangle because those two angles are equal to each other. And we have the rule that in front of those two equal angles in the triangle AMB, we have those two sides that must be also equal to each other in their lengths. But AB is 10, therefore side AB must be also equal to 10 units in its length. Our task is to find out the area of this quadrilateral ABCD. What is the area of this quadrilateral ABCD? It is equal to the area of the big right triangle MDC minus the area of this one right triangle AMB. And again, the area of this quadrilateral ABCD is equal to the area of the big right triangle MDC minus the area of the small right triangle ABM. The area of the big right triangle MDC equals to the base DC times the height MD over 2. But again, the area of the big right triangle MDC equals to the base DC times the height DM over 2. Minus the area of this small right triangle ABM. The area of this right triangle MBM equals to the base AB times the height MB is equals to the base AB times the height BM over 2. And again, the area of the right triangle ABM equals to the base AB times the height BM over 2. DC is 25, MD is also 25. So in total, the area of the big right triangle MDC equals to 25 times 25 over 2, minus the area of this small right triangle ABM. The area of the small right triangle ABM equals to the base AB, that is 10, times the height BM, that is also 10, divided by 2. So in total, the area of the small right triangle ABM equals to the base AB, that is 10, times the height BM over 2. 25 times 25 is 625, minus 10 times 10 is minus 100, divided by 2. 625 minus 100 is 525 over 2. 525 over 2 is 262.5 square units in size. So in both methods we found out actually that the area of this quadrilateral ABCD is equal to 622.5 square units in its size. Okay, thank you very much.